For this final project, we're going to explain integration by parts, who made it, and give some examples so you can understand the topic as a whole.
Now I will explain the origin of the formula for integration by parts. Brooke Taylor, who was born in 1685 on England, was a noble Englishman, which this led to a high level of education in the English society. He was a mathematician, and later on in his life, he wrote 2 books, and on one of these books, the formula for integration by parts was mentioned, and also another theory which is called Taylor's expansion.
Now I'm going to explain a little bit about the formula of integration by parts. The formula is integral of u dv equals uv minus integral of b du. And in order to determine which is going to be the u, we need to use late in this order. First is logarithmic, then algebraic, then trigonometric, and at the end is exponential. And just a fun fact, the original formula was way longer, but this is a simplified version that also works to solve the problems. After you know what the u is going to be, the rest of the formula is going to be dv. And also, in order to find the b, you need to integrate dv, and in order to find du, you need to find the derivative for the u.
Now we will proceed with our first example for integration by parts. The first example is find the integral for 6x sine x. So first, we need to state our values. So we're going according to late, and our u will be 6x. And our dv will be sine of x. I forgot the b. So we get the derivative for 6x, which is 6 dx. And then we get the integral for sine, which is negative cosine of x. Now we need to do only according to the formula, the original formula, our values. We just need to plug in the 6x times cosine to the x minus integral for, again, negative cosine times d. So now we can multiply these factors. Cosine of x. Since it's negative times negative, it becomes a positive, and we take out the 6, so we can integrate cosine x. And by finding the integral, we get sine x. So our final answer is negative 6x cosine plus 6 sine of x plus c.
And now we will do another example, but with the tabular method. The tabular method is like another way of doing integration by parts with certain types of problems. You can also do it with integration by parts, but it's best used with this one. So we will start. Our problem is integral of 5x3 cubic dx dx. Now we have to establish our values, which are u and dv, just as integration by parts. But the difference is it's going to be, well, the table, and you're going to have to put the signs. The u is going to be 5x cubic following late, and the dv is going to be the rest, which is e2x. Sorry. And then you want to integrate this, which is derivative, this, which is 15 and 0. Then for this, you're going to find the integral of this, which using substitution and since we now know that this is the integral, we can just repeat the process multiple times until we get to the 0 that is here. And the signs, we're going to start with positive, negative, positive, negative, positive. 1, 1, 1. Then what we do is go across and down. You might be wondering why, but that's just the formula. Okay, and we don't include the 0 because it's, well, 0. So then we're gonna multiply this times this times this all in one, and that's gonna give us our final answer. And don't forget plus C.
In conclusion, we learn about the great history this formula has through time.
And we also learned the formula of integration by parts, and that before it used to be longer.
We also did some examples doing by parts and the tabular method, which is similar.